Hey, welcome back to IED. Today we're going to be taking some notes on density. Well, what is density, Matt? Density is our equation is mass equals density times volume. All right, M equals D times V. Other ways that you could see this exact same equation is sometimes you'll see it that density equals mass over volume. I just happen to know that from algebra, teaching algebra for so many years, that students make a lot less mistakes with that equation than they do that. Both of them will give you the same answer, so it doesn't really matter which one you use. If I notice you're making mistakes and you're using this one, I'm going to come over and have you use this one. You'll make less mistakes with that equation. But they are the same equation. Units for density are typically going to be grams per centimeter cubed, but all right, density can have any units as long as they are mass divided by volume. It could be kilograms over meters cubed. It could be this would be weight density. These are here are mass density. Sometimes they use what's called weight density. It could be pounds over inches cubed. Um, Again, that'd be weight density because we're using a weight. These are here with mass density because we were using masses. But, all right, so let's do a little review. Volume. Well, how do we find volume? Volume for a box-like object is length times width times height is the volume. Equation for things that are cylinders would be pi r squared times h, which is the height, r being the radius. And if we have a liquid, every milliliter it moves up, we could say that has a volume of 1 centimeter cubed. Though also it goes by, so we're going to measure the amount of displacement in a beaker or graduated cylinder. So let's say I have this beaker, and originally the fluid was up to here. All right, and that right there was at, let's say, 10 milliliters. We put this object in it. All right, doesn't matter what the object is, and now the water moves up. It's now at this new reading. It's at 17 milliliters. Well, what's the volume of this object? 17 minus 10 gives us 7 milliliters. So this increase in volume had to be due to one thing: the object we stuck in there. Henceforth, it must have a volume of 7 milliliters. All right, we got some examples here. Find the density. All right, we're going to put it all together now. Got this box-like object. Well, for a box-like object, we're simply going to take the volume, which is length times width times height. 8 times 11 times 9 equals 792 cubic centimeters. My equation then for density is mass equals density times volume. The mass they're giving to us to be 10. The density is what I want to find. The volume is 792. Before I go any farther though, the mass here was in kilograms. Our units were in centimeters. So I'm going to convert this from kilograms into grams. That tells me that, if I go by my table up here, I have grams. We then would have decagrams, or sorry, deca, or sorry, go, hecto, kilo. So that means I'm going to move 1, 2, 3 spots to the left. Oh, sorry, I'm in kilo, I'm going to go to grams. 1, 2, 3 spots to the right. So that gives me 10,000 grams. So I'm going to change this to 10,000 grams. The density here turns out to be 12.6. Well, 12.6 what? I took grams and divided it by 792 cubic centimeters. So my units on this would be grams per cubic centimeter. Okay, I've got a cylinder. All right, to find the volume here, I got pi r squared times h. It's 5 centimeters tall, has a diameter of 1.6. That means its radius is half that, or 0.8 centimeters. But we took the diameter and half of that was the radius. So I'm going to put in 0.8, 3.14 times the volume here. Okay, our volume turned out to be 10 point, I'm going to round this up to 0.05 cubic centimeters. Now I'm going to find the density. Mass equals density times the volume. The mass, they give me, oh nice, it's in grams already. Density, and then I get 10.05. I'm going to divide both sides by 10.05. The density here turns out to be 19.9 grams per cubic centimeter. One more to go. Graduated cylinder goes from 40 milliliters to 43. Well, if you remember, the way we find the volume of this is we subtract the 2 milliliters. So here we took 17 minus 10. Here I'm going to take 43 minus 40. So 43 minus 40 gives me 3 milliliters, which is my volume. I'm going to give you a little secret here. 3 milliliters is equal to 3 cubic centimeters. We have this little conversion. 1 milliliter equals 1 cubic centimeter. So I'm giving that to you. It's Christmas, all right? Not even Christmas yet. Actually, it's not Christmas, and I am giving you this gift. All right, write that down. Now, so I'm going to use my density equation, mass times volume. Oh, shoot, I wrote that wrong. Mass equals density times volume. The mass in this problem is 5. Density is what I want to know. The volume is 3. So the density turns out to be 1.67, and it was grams, and I divided it by, you could say milliliters, but typically we're going to write this as 1.67 grams per cubic centimeter. And the reason is, again, is that 1 milliliter equals 1 cubic centimeter. That's just a conversion. I would write that down and be ready to know that and recite that. Well, hey, that's it for today. I'll catch you guys on the flip side.